Good evening. Today we'll start our problem solving class. So I'm Purvita Shamanto and the course Building Materials and Composites is coordinated by Professor Shumana Gupta of IIT Kharagpur. So in this session we will do some questions on ferrous and non-ferrous metals. So, like every week, we are doing this class from 6 p.m. to 7 p.m. So, any questions you have, you can always raise your hand and answer. And above all, we'll have some of the questions already set for you, so you can answer. And the questions that we keep, you'll have already those who are coming regularly. You'll have seen that it helps in solving the graded assignments. So, a recap of week 6 is introduction to different metals. Ferrous metals, cast and wrought iron. We saw in the video lectures, ma'am talked about steel. We also had a lecture on reinforcement bars, corrosion, or rather, how to prevent corrosion, and light gauge steel. And lecture 30 was all about non-ferrous metals, for example aluminium, copper. These things were taught. So for today's live session, what do we have? We have theoretical questions and a few pictorial questions like every week, and today also we do not have any numerical question. So coming to the first question, so the first question says that by ductility of metals, we mean that metals can be. So can I get the answer from you all? Okay, Harsha says it's B. Any more answer from anybody else? Yes, absolutely correct. So it's basically the property of metal by which we can draw the, by which we can pull the metals into thin wires or bars. So that property is basically known as ductility. And apart from that, we have also seen that in the video lectures, there are a discussion on different other properties of metal. For example, metal have got high density, low porosity. They are more durable. They are weather resistant with appropriate treatments, of course. And then there are several other properties. For example, elasticity is there, plasticity is there. Plasticity basically means how easily you can shape or mold a particular metal. So we have seen, in fact we'll see how this we can provide different shapes and all. Ductility is basically this drawing to bars or wires, how you can pull the metal. And there are metals are also capable of resisting deformation in response to an applied force, which is basically known as stiffness. It's also malleable. We can make thin sheets from the metals, and forgeable, of course. We can change the shape, and we can make into any desirable kind of shape as we want. So these are some of the basic properties that any metal has, but today's focus will be on the ferrous metals and of course non-ferrous metals as well. Okay. So our next question is, during the smelting process, which of the following compound is added as a slag? And the options we have are limestone, carbon dioxide, dolostone, and hydrogen peroxide. Yes. Okay. So it says A. Any more answer? Okay, so the answer is yes, it's limestone. So limestone is basically added during the smelting process, and it acts as a slag. Now, what this smelting process is? So we know that iron that we are talking of, it has different grades. Okay, but leaving all those grades behind, the first thing is that how do we get iron? So iron is not readily available. There are iron ores, and from those iron ore, iron needs to be extracted, and then again on further purification or upon further treatments and processes, we get different grades of iron. So this is the basic concept of extracting iron. So when we talk about smelting of Just a second. Yeah. So when we talk about smelting of iron, that means what? The iron is being obtained from its core. So how do we obtain it? It's heated beyond its melting point, and also there are usages of some kind of agents. For example, air or reducing agents such as coke. So all these things mix up to give to ultimately give the iron that we want, and also limestone is added, which acts as a slag. So limestone, it decomposes and slags are formed, and then finally we get the molten slag is also present, as well as the molten iron is also present. So due to their density differences in the density, so they form two different layers, and the slag can be extracted and the molten iron can be extracted. So, upon the first stage extraction of this particular iron ore that we get from nature, we get what we call as pig iron. So again, pig iron on different, after going through different processes, we'll get the different grades. But before we move into the discussion about further from pig iron, how what happens, let's look into our next question. Okay, so the next question says that the pig iron is manufactured in which type of furnace? Blast furnace, cupola furnace, induction furnace, or reverberatory furnace? Okay, yes, Harsha and Balu, both of them says option A, Rohit also says, yeah. So it's basically blast furnace. Now this is fine, but now let's see how this entire process is carried on. So we already studied that iron ore is there. So using blast furnace, we get this iron ore. Pig iron. Now pig iron is basically made by melting iron, charcoal, limestone. So what we were talking about, that the first extraction. So that is what pig iron we are getting. Now this pig iron is again melted in different processes. So if we use this cupola method of extraction, so here what happens, from here we get cast iron. So cast iron, here also in cast iron we use pig iron is melted along with the scrap iron and coke within a hot air blast, and then we get what we call it as cast iron. Now then coming to wrought iron. So when we use this puddling furnace, then what happens, this pig iron is basically again oxidized along with iron oxides, and that also in a puddling furnace. So this is a specific kind of a furnace, and then what we get is known as wrought iron. And another very commonly used method, from which is used in order to get steel from pig iron, is basically Bessemer converter. So apart from that, open hearth furnace or electric furnace or any basic oxygen process is also followed in order to get steel. Now all this cast iron, wrought iron, steel, all these things that we are getting, there's a basic difference, that is the differences is in the carbon content. So that is what basically makes the differences in the type of iron, and also in the differences in the type of usages. And once also of course, the other property, that is the structure of the material, I mean the type of iron we are using, so that also differentiates the kind of usages as well. So when we look finally, when this pig iron is melted, and manganese, nickel, and chromium, all these things are added, we basically get steel. And then further, this steel can be rolled, it can be pressed, and it can be forged. So those things we will again discuss later as we move forward in this particular lecture. Uh, but that is what basic process of getting this different types of iron. Now the next question is basically, so what I said is that there are differences in the carbon content. So that is one of the major property that differentiates all these types of iron, and also where we are going to use or how we are going to use. So we have to arrange the following metals in the increasing order of their carbon content. So basically the first one will be that particular iron that has the least amount of carbon in it, followed subsequently followed by the uh, um, ions which is having a little more carbon content. Okay, so I get the answer B. Okay, 2, that means wrought iron has the least, then steel, and then cast iron. So any more answer from anybody else? Yes, absolutely correct. So if we look into the carbon content of cast iron, so it basically has high carbon content, which is something around 1.7 to 4.5%. And then wrought iron has got the least carbon content, which is mostly less than 0.15%. And steel has got a carbon content of something around 0.5% to 1.5%. So it's basically steel is something which is in between the carbon content if you look. So it's just in between the cast iron and the wrought iron, right? Okay. So next, coming to our next question. So it says that arrange the following metals in their increasing level of the ease of welding. So basically, what you have to find out is that increasing level. When I'm talking about ease of welding, it means you have to find out the least, uh, you know, uh, ease since we are talking about ease of increasing level of ease of welding, so the option that we'll have at the least last will have the easiest, you can weld it in the easiest way. So that is what this question talks of. So we have high carbon steel, we have mild carbon steel, we have wrought iron and cast iron. So in order to answer this question, if you remember, there was one particular slide from the lecture where it was represented like this, difficulty levels, and difficulty level is high or difficult or easy. And so if you remember that particular slide, so on the other hand, there were this, different grades of steel, sorry, grades of iron, and either it's difficult or easy. Okay, so I got one answer. Yes, it says option B. Okay, let me see. The answer is option C, which means that, yeah, which means that 4, that is cast iron, is the most difficult to be welded. Okay, and then the next one is high carbon steel. So after cast iron, it's the high carbon steel that is most difficult to be welded. Number 2, that is mild carbon steel. So next comes mild carbon steel, and the easiest to weld is basically wrought iron. Okay, so that is what the question was, to understand what is the level of, what is the ease of welding. Also, you'll find in that particular slide that which of, the increasing or decreasing order of the tensile strength. We'll also discuss that. But as of now, let's move to the next question, which basically asks you to match the type of iron with its corresponding compressive strength. So we have, what do we have? We have cast iron, we have wrought iron, and we have steel. And on the other side of, on the the column just beside it, we have the different values of compressive strength given. So 1000 Newton per millimeter square, 50 Newton per millimeter square, 600 Newton per millimeter square, and 200 Newton per millimeter square. So you have to find the correct answer. Okay, I got one answer which says C. Any more answer from anybody else? Okay, there's an answer with D as well. Harsha says B. Okay, so let me see what is the correct answer. Absolutely right, Harsha. So it's option D. So cast iron, it has got a compressive strength of something around 600 Newton per millimeter square. Wrought iron has it has compressive strength of 200 Newton per millimeter square. Steel has got 1000 Newton per millimeter. Now, this 1000 Newton per millimeter square that I have written, it can vary. So it depends upon what kind of steel you are using. So it may vary from, maybe 1,000 Newton per millimeter square. It can also go up to 1,200, something like that, and it can also come down to 750, 800 Newton per millimeter square as well. But if you look into the the average value of the compressive strength, it's something around, it can be considered like it's obviously the one thing that you can understand from the options itself is it's higher than that of cast iron or wrought iron. So the options that we have, definitely, 1,000 Newton per millimeter square, the compressive strength of steel is. Also in the lecture slides, you'll find it in kg per centimeter square. So you can just convert it to Newton per mm square. So any with any unit that you get, ultimately the values will be something like cast iron. Steel is having more compressive strength than that of cast iron and wrought iron, whereas wrought iron has the least. So yes, now coming to the tensile strength value. So you can see that cast iron has tensile strength of 150 Newton per mm square. Uh, Wrought iron has a tensile strength of 40 Newton per mm square, whereas steel has got tensile strength of something in the range of 700 to 1000 Newton per mm square. Now again, this can slightly vary. Like, these values are not the rigid value, so it can vary upon the types of steel that we have. Okay, so we can say that cast iron have higher compressive and tensile strength, and that is one of the reason why long span bridges are built using this cast iron. However, we also read in our lecture, this video, that although cast iron, they have got higher compressive and tensile strength, but due to the structure, due to the internal structure of cast iron, it can break at any point of time. So this is one of the drawbacks of using cast iron. However, we can always see that it has got compressive strength and tensile strength more than that of wrought iron. Now coming to the wrought iron part. So wrought iron is it's the purest form of iron, and it has negligible impurities. Hence, it can be forged easily. How steel pipes are manufactured. If you ask me about how they are manufactured, then I'll just go into different processes of steel manufacturing, I guess. Like we said that, I'll talk about one process. So I think maybe after that you'll be able to understand, and then only I'll discuss. Other than that, also the pipes that you see, they are also, cast iron is also made to use pipes, because they can be, cast iron can be molded easily. Although it riveting and welding is not possible for cast iron, which whereas riveting and welding is possible for wrought iron. But yes, we also find different staircases made of cast irons. Of course, bridges and long span bridges are always there. I'll give example at the end as well, and you'll have also studied it in the lecture. But coming to the, I'll talk about the steel pipe in particular. Once, I think you yourself will be able to answer it. Okay. Okay, so here comes one of the question which will help you understand. Uh, so what the question is? So the question talks about, during hot rolling, the metal temperature is. Okay, I got one answer. Harsha also said okay. Yes, the answer is it's greater than its recrystallization temperature. Okay, so if you look into this, this two images, you can see that the first one, this one, it's how hot rolled steel is basically, or the hot rolling of steel is done. So you can see here that steel is undergoing a rolling process at a temperature which is above its recrystallization temperature. And then on this side, if you look, this is cold rolling. So cold rolling is basically the process of strengthening the steel by changing its shape without heating. So can you see the, this steel sheets? So this cold rolling, just a second. So this cold rolling is basically, it's any kind of processing is done when we are doing this roll cooling thing, cold rolling thing, which is below the recrystallization temperature. Now, what are the outcomes of this hot rolled steel, and from this cold rolled steel? So from this hot rolled steel, you get a very scaly surface, slightly rounded edges and corners, and the surface is non-oily. Whereas from cold rolled steel, what we get a very oily or a very greasy finish, and very smooth surface, and very sharp edges. So this is how this particular steels are, they undergo different kinds of rolling, either the hot rolling or the cold rolling, and then they are manufactured into the particular kind of requirement that you want to have. Now coming to steel pipes. So steel pipes are basically hollow tubes, you can say. So the steel pipes, they are also if you want to understand the manufacturing, this after this different types of processes, they are also casted in that way. So only after that you can get steel pipes. So in particular, do you want to ask anything about, like, if you ask me about the exact process, like how they are formed? So generally it's like, there are the sheets of steel, and then they are rolled, and then they are properly welded and pressurized. So that is how I understand steel pipes are formed. But apart from that, do you have any other question, like, or maybe I couldn't interpret the question in the way that you wanted to be answered, Sumit? Okay, I don't find anything else. So basically, it's okay. So it's basically we mold the steel into its into its workable form in whichever way you want to cast it. So only after that you can get it's pressurized. Basically, there's a series of process that goes through. It's welded, it's pressurized, and then the final outcome we get. And prior to that, it can be either hot rolled steel or it can be cold rolled steel. Okay. Now moving on to our next question. So the abbreviation of HYSD bar is, okay, I got one answer B, high yield strength deformed. Okay, so this is quite a straightforward question, which basically talks about HYSD, high yield strength deform. But what's important for us to also understand is what's this high strength, this the deformed bars are. So these are basically, you can find all the the specifications in details in IS 178 and 1985. So these high strength deformed bars are basically nothing but steel bars. Okay, so that is fine. But apart from that, they are widely used in the construction industry, and they have got some kind of ribs and projections or some kind of deformation on the surface, and they are produced in the form of either cold twisted way, or hot twisting is also done. So these bars are basically, if you look into the usage. So they were one of, if you acha, see, if you look into steel in general, the tensile strength is not that high. But when it comes to high yield strength deformed or HYSD bars, so this was one of the invention in the construction industry, where the tensile strength of the bars could be increased. And this particular particular material, this particular reinforcement bars or rebars had could be used in it can be used widely. So this is one of the thing which came with the invention, or rather with the manufacturing process of this high yield strength deform or HYST bar. But apart from that, there were also several other problems that was associated with this particular HYST bar. That is, there was this surface deformation. So generally, what happened? Cracks could be developed. And also, if you talk about corrosion, corrosion is one of the important thing which we need to resist or avoid when it comes to steel and iron and all these things. So corrosion was a huge problem when this HYSD bars were used. So in order to avoid all these things, or in order to get something alternate to this particular HYSD bar, this TMT bar came into place. And this TMT bars are basically thermomechanically treated bars, and they are also high strength reinforcement bars. If you compare, if you ask me that whether TMT bars have got more tensile strength than HYSD, it's mostly comparable. Like, it's not you can't really say that in terms of tensile strength, you can't say that HYSD is very poor, has got a very poor tensile strength in comparison to TMT. It's very much comparable. But also, what goes into TMT bar is that it's the way that we manufacture, and also it's the way how it is corrosion resistant, and it's the way how it doesn't develops any kind of surface cracking. So this are some of the important things when it comes to TMT. And if we talk about TMT, so TMT bars are basically subjected to water quenching, okay, whereas this high this HYSD bars, they are generally subjected to heat rolling or cold twisting. So this TMT bars, they are manufactured under the process which is known as thermomechanical treatment. That is why they get the name TMT. And this hot rolled steel billets, they are passed through the water, which hardens the surface, and basically it increases the tensile strength. So that is what quenching in the water is all about. Steel billets are basically small steel, or basically small steel that are, or maybe you can say just freshly prepared steel. Like, they are still not given any kind of form, rather they are in the form of small uh, chips or small bars, and they have been just produced using this Bessemer process, and those are basically steel billets. So these are used, and then finally we get what we known as TMT. And as I said, when I there are advantages of using TMT over this HYSD bars. Okay, so I hope this thing is clear. And now coming to our next question: the maximum amount of carbon content present in the steel reinforcement bars is. Okay, I got one answer. Sumit says B. Any more? Okay, no one? Yes, the correct answer is 0.25%. Absolutely correct, Harsha. So basically, also, if you once again, like, referring back to the lecture material, if you go back, you will find that 0.3 percentage of carbon content. is sufficient to get high strength reinforcement bars. Okay, so always remember this one. So generally it says that this percentage is sufficient. So 0.25 percentage is it's generally taken as the limit, the maximum amount of carbon content which is present in the steel reinforcement bars, and it will basically give you a very high high strength reinforcement bar. So this is what you need to remember when we are talking about the carbon content of steel bars. Now coming to our next question. Which of the following gives the strongest joint of metals? Okay, I got one answer. No more? This is quite a easy. Okay, okay, chalo, chalo. Thank you. Yes, absolutely correct. Welding is welding is the one of the process which gives you the strongest joint. And if we look into the different processes, so soldering is basically the process where we use a particular kind of alloy. Okay, now I guess it's visible. Yes. So we use a particular kind of alloy. So that metal alloy is known as soldered, and that particular alloy is melted and it is applied on the metal parts which needs to be joined, and that basically helps in the formation of, or that basically helps in in the connection of this one metal with the other metal. Once this particular alloy or the solder it solidifies, this particular two metals gets joined. Very in a very similar process. Brazing is another process where we again use a filler metal. So here what we use is known as alloy. It's which is having a comparatively lower melting point. On the other hand, in case of metal, the only difference is that we use another filler material. So here what happens, the two pieces of metal are the two pieces of iron, you can say, or steel. It's basically joined with the addition of a particular filler material, and this filler material is also having a lower melting point. So this is quite important property when it comes to you know uh, using this process of soldering and brazing. And when this particular metal is basically then this filler metal is then placed, and then it is hammered. So after that, once this hammering is done, it's left for few for a certain period of time, and then this two gets joined properly. Whereas when it comes to welding, welding is one of the process where you do not use any kind of other alien material. So it's basically you are fusing the two metals together with the help of heat. So with the help of heat, you are basically heat is the only thing that we use here, and then by pressurizing and then after further cooling, this two metal parts join. Also nowadays there are different types of welding. When it comes to welding also, you can find that there's this gas welding, and then there are other types of weldings as well. And you have, I think all of you have seen that particular machine that is used particularly where they produce steel doors, steel gates, and all those things. So you have seen how they join. So it can be a tungsten welding. it can be, some other inert gas usage or some. There are different types of this particular welding process as well. Okay, now coming to our 10th question, which says that, so this is basically a question. Okay, there's this one particular space will be here. So it's a question regarding the corrosion. We have seen that how important it is to, make the surface of the metal resistant to corrosion, because once corrosion starts happening, then there are, basically what happens in the presence of air, in the presence of basically moisture, what happens, the metal, the surface of the metal, it starts reacting, it oxidizes. And then what happens, there are this thin layers or flaky layers which starts forming, and it starts corroding. So this entire thing is basically what we call it as corrosion, or rather rusting. In case of iron, rusting happens, and this basically leads to the corrosion of the metal. So this is something we need to resist. And so there are different methods through which we can resist this corrosion, and those includes, metal plating, coating with claddings of organic substances, or you can use anodic coating. So the thing is that what you have to do is that, so on left side we have this different protective methods, and on the right side what we have, how these things are basically done. So that is all about this particular question. So yes, do I see any answer? Okay, I got one answer. Okay, this is a bit, it has got two. One option can have, like, P is having two answers. So just a second. Hmm. Any more? No. Absolutely correct, Balu. So it's when we talk about metal plating. So metal plating is basically electroplating with the use of nickel or chromium, and also it also involves, galvanizing in molten metals such as zinc. When it comes to coating with claddings of organic substance, it's basically the epoxy materials that we get, or the acrylic polymers that we get. So that is what, this coating with organic substances is all about. And the third one, that is anodic coating. So this anodic coating, this is basically with the use of aluminum oxide. And I think we have all, during our school, we have studied about this anodic coating. And let's just see, this particular image will help you to understand, what this anodic coating is all about. So if we talk about anodic coating, is basically, utilizes anodizing. It's the method of anodizing, to provide a certain layer above the original metal. Okay, so that you can resist it from any kind of, it acts like a film, a layer of over the actual original metal. So it basically helps it, in, of course, the first is that you can, prevent the metal from getting it corroded. That is the basic thing. Apart from that, you can use this, anodized layer as a good base for painting. And also you can use it as a, decorative finish. If you look into, I haven't provided any image of, anodized surface, but if you just go and search, this anodized surface, how it looks, you'll find it has got a very, shiny, and a very, it looks very nice. It has got a very sophisticated finish as well. So you can always, you can use it as a decorative finish as well. So that is why, anodic coatings are all very much preferred. So generally what happens is that, if you look into this original metal part, so this is the original metal that you have, and then on top of it, a particular, there this is just a very simplified version of what it is shown. Like, there is this original metal, then there is a barrier type oxide layer, and then there's cellular oxide layer, and then, this, you can see this kind of thing. But if you actually, like, go into the deeper, how each and every step is done. So over this original metal, first it's cleaned. So there are different impurities present on the metal surface. So it's basically first, the obviously the first step will be to clean. Also the cleaning process, it has got, it's very elaborate. Then what happens, then some kind of, this, the metal surface is, some kind of depressions are made, so that this particular, if you look into this particular, you know step, you can see that it's not anymore a straight kind of a thing. So it's basically there are some, depressions, and then over it, this anodizing is done. And also it's filled with, this dye or color deposits are then done, and also over it, it's sealed sometimes with, with a particular film. So these are different processes. This particular image has got, it is just a very simple thing, just to make you all understand like how these things happen. Okay, so I hope this was clear. Now coming to our next question, which says that match the following and select the correct combination. So in this correct combination, what do we have? So first we have this non-ferrous metals in our left hand side. So we have aluminium, we have zinc, we have lead mixed with tin, bismuth, and cadmium, and then we have copper. So okay, so I started getting answer. Harsha says option B. Any more answer? Okay, B. Okay. Yes, absolutely correct. The answer is B. Aluminium, we have seen like this is something, this metal is something which is widely being used in the construction industry at present. And we are, you can see any kind of, door frames, window frames, all are nowadays, you'll hardly get any, this nowadays you'll hardly get any timber of, doors and windows. Even if you get doors like, with plywood and all, windows nowadays it's all about, using steel grills, and the frame, or this entirely aluminium, using aluminium frame and aluminium, this sliding windows. So this is something which is, widely being used. So of course the answer will be P3, used in door and false ceiling frames. Also, there's if you all are aware about how these false ceilings are done, false ceiling, first, there's this particular kind of a cage that is done. So this, if you imagine it, I hope you all are understanding, this is in plan. Okay, so if you look into the plan, so those who are into this, I hope all of you are into this particular construction field, like either engineers or architects. So you all have seen the reflected ceiling plan, or the false ceiling, plan basically. So you can see that how this, these frames are basically, if you look into the details of this reflected ceiling plans, and where this false ceiling is being done. And of course it's important that false ceiling is being done, and you find that there are this aluminium frames first made, and those are, if you look into, from the elevation point of view, they are basically hung like this, and it's attached to the ceiling with the help of, some kind of, and these frames are hung. So these frames are basically all made of aluminium, and then the gypsum board is used to, cover this particular in between spaces. So this is one of the commonly used method when we talk about false ceilings, gypsum, use of gypsum board and aluminium frame. Okay. So next is zinc. So zinc is basically, it's immune to harmful effects from UV rays, as well as this is one of its property. And also it forms a protective coating on iron and steel in paint form. So zinc coating, I think this is very commonly heard terms, zinc coating. is being done. And then lead is when mixed with tin bismuth cadmium, then we get we can use it for plug in fire sprinkler nozzle. Lead has got several disadvantages when it comes to environmental environmental concerns. But anyways, nowadays the use of lead has been reduced to a great extent as well. And then there's copper. Copper is, of course, is used for making brass and bronze. And these are also, we have seen that, in our lecture video lectures, that copper is extensively used for making these electrical wires. Yes, so these are just some of the images where you see this aluminium door frames, made of basically door frames are made of aluminium. And also this nozzles, sprinkler nozzles, which are used to, also sprinkler nozzles, sprinkling a sprinkler system. This entire sprinkler system is you can again go back and if you all are into these drawings and all these things, you'll find that how the drawings are done, how the sprinklers are positioned. So that's a very different thing, that's not a part of our material part. But yes, this is also another thing. And then what happens in a Bayes process? So this is another very easy question. Okay, I saw there's this another question. Why zinc is immune from UV rays? Okay, so basically this zinc oxide. Okay, so this zinc oxide, it has got its properties. It has some nanoparticles and all these things, which basically uh, helps in the absorption of this UV rays. So that is what one of the property of zinc is all about. So why zinc is immune from UV rays is a difficult question for me, but that is what I know. It has got each and every kind of material, they have got this absorption spectrum. If you talk about any particular material, so any particular material, it absorbs a part and then it reflects and also transmits. So this is something we all are aware. And zinc has got that particular property because zinc oxide rather. So that is why it's said that, or the option is correct over there. Okay, let me check the other. Okay, so B. Is this okay, Sumit? Acha. Yes, absolutely correct. So what happens in Bayes process? It's basically aluminium oxide is extracted from bauxite. So if we talk about Bayes process and if we talk about this aluminium, so basically bauxite is you know it is the most important iron ore of aluminium, and it contains something around 30 to 60% of aluminium oxide. So that is why bauxite is basically used in the process of extraction of aluminium. So also when we talk about process of extraction of aluminium, it basically goes through four important steps, that is digestion, clarification, precipitation, and calcination. So this is basically a very, once again, a very simplified image that shows that bauxite is put into the mixer, slurry mixer, and also this particular caustic soda or NaOH. This is a very important ingredient which needs to be put inside the slurry mixer, and then it goes through the process of digestion, clarification, and then further precipitation and calcination, and then finally this aluminium is extracted. So this is in Bayes process is basically the important or the major industrial process of refining bauxite and producing alumina. So this is all, like this is how as simple as I can explain regarding this Bayes process. So if you look into this particular, this flow chart also, you'll see bauxite, then it's grinded, then it's digested at a certain temperature, which is generally around 170 to 180 degrees Celsius. And then further, it goes through different types of clarification, evaporation, all these processes happen eventually. And then finally, it goes through, once clarification is done, its precipitation is or basically precipitation happens, and then further upon calcination at 980 degrees Celsius, we finally get the thing which is called alumina. So these are once again very simplified things, but it's enough for us to at least understand how the things are. And by now we have already understood that how this different types of, our major goal is to understand that where we can use these different kinds of metals, be it ferrous metal, be it non-ferrous metal. So in ferrous metal we have seen how widely, we are using this not only steel structures, but also when it comes to, using concrete in order to provide the tensile strength to the concrete, we use this steel reinforcement bars. Now till now we knew that we are using steel reinforcement bars, but today, or rather in this past week, we have seen that even steel reinforcement bars can be of different types, and according to, their properties also, we can use this either TMT bars or H5ST bar. These are something with that we have learned from this particular module. So let's, as I discuss like every time, let us see some of the some of the structures made of steel or iron. Not exactly, like not all are steel, but yes, iron we have very few examples only. Like one example I've given. So this is something that we have already that ma'am has already discussed. And this yes, any guesses regarding the name? This is the first cast iron bridge. This is known as, yes, no one remembers. Okay, I'll give the answer. It's the Bridge or the Cole-Brookdale Bridge. This is also known as Cole-Brookdale Bridge, and this is in England. And it was opened in 1781. It was something. If you understand the timeline, it was a result of the Industrial Revolution. So again, the Industrial Revolution is a different, where basically this use of steel and glass, this came into place, and anyways, so this was the first major bridge in the world to be made of cast iron. Then it's, any example, anywhere you look, you'll find steel and all these things. Okay, this one, anyone can guess this particular structure. This is also a very well known structure, and this is one of the skyscrapers that in that was built using steel. And no one, this is a very famous structure. And also, if I give you a hint, anyone, any architect, where any architect over here is present, so it was designed by what's the name, Daniel Burnham. This is the Flatiron building of no, no, no. Acha, I don't remember whether it's Wall Street or not, but this is in New York. The and John Wick, no. By This is the Flatiron building by Daniel Burnham. There was another architect as well. I don't remember the name, because Daniel Burnham is someone whose buildings and whose works we read frequently. Okay, this one. This is a bit on the tougher side, I understand. So this is basically Tokyo Sky Tree, and this is a tower which is made of steel. And okay, this one is again a very well known structure. This was one of the tallest building in the world when it was built. Yes, Akash. It's the Empire State Building, and if we look into its construction techniques, you'll find that it's basically steel columns and beams that forms the entire structure. And apart from that, there's this, I guess, there's this limestone cladding, like there's this particularly what Indiana grade limestone clay or something like that. Anyways, the basic structure is of steel. However, if you get a very close up to this, I didn't put any images to close up images. But if you go and find the zoomed images, you'll see, or if anyone has visited, even they'll know that it's basically cladded. The entire structure is cladded with stone, and but the main structure is of steel. Everything is of steel. Steel columns, beams, everything. And also you can find different interior images as well, where you will find that how the columns are basically placed, the steel columns, and it's a marvel to look at. Okay, this is something uh, we all know, but what's important is a story behind it. Yes, this is in India. Yeah, it's the Howrah Bridge, and so this particular yes, Akash Abhilash. So this particular bridge, it has got this 26,500 tons of steel, and out of which it says that 23,000 tons of high tensile alloy steel was used, and this entire steel was supplied by Tata Steel. So this is one of the huge structure, one of the structure that used huge quantity of steel. And apart from that, what's also important, yes, I think many of us have heard about that. It is a cantilever beam, sorry, cantilever bridge. And also this particular bridge has got not a single nut or bolt. So we have learned in our video lecture that in order to join metals mechanically, you can screw it, or you can use bolts, okay, or you can rivet also. So that, but this riveting was done for this entire structure, and you won't find a single this nut and bolt being used, except later on, like I think in the past 6 or 7 years, or maybe something like that, like in within 10 years I remember this. So there was the columns, the piers, basically they were you know uh, given a covering from outside. Only this particular thing, this covering was basically provided so that it can be prevented from corrosion. And people used to spit this gutka and all these things, so in order to prevent this fires from this corrosion from that particular substance, this metal covering has been provided, and only this metal covering is attached to the ground using this nuts and it's screwed. Other than that, not a single part you'll find which is having any nuts or something like that. So this is another, it's a beautiful example of a steel structure. So that brings an end to today's class. So any question from any of you? If you all do not have any question, thank you, Harsha. Thank you for joining. Also, we have 2 more weeks left. So the next week and the next to next week. Thank you, Rohit. So I hope you all will join in the next class as well. So let's call it a day. And once again, thank you for coming. Thank you, Marvin. Thank you, Akash. Rashmi, thank you.